In this series of lectures, we're going to look at reconciling perspective using projection techniques, and also a little bit about spherical panoramas. And at the end result will be a shot kind of like this one. Before we get into the nuts and bolts of it, let's talk a little bit about the theory. Now, we're going to be using a spherical panorama, which conceptually is just a ball that is shot from the point of view of the camera. So if the camera was to shoot every single direction out and be projected back onto a ball, we would have a spherical panorama. And if you remember the lecture that we did for the tile world exercise, you can think of perspective almost like radiating in towards the camera. That's not the way it's typically taught when you talk about perspective in a traditional sense with vanishing points and all that stuff that you learn in school. But I like to think of perspective sort of really more like actually radiating away or radiating in, however you want to think of it, towards the viewer themselves. And that's pretty much what you get in the classic view of perspective. It's just that you now have to think, well, what would happen if I looked behind myself? You know, this horizon's gonna continue to spin around you until you essentially get this spherical panorama. The only real cue to depth in this situation, or the only thing that matters really, is the field of view, because all of the perspective is related to that field of view. So if you had something that was a subset of that field of view, you could easily insert that into the wider field of view, let's say, if you could just calculate what that subset of the field of view is. So it would just be a projection, really, a small projection of slice of your overall field of view. And a spherical panorama is a 360 view, so unless you had another spherical panorama, you couldn't just lay one on top of the other and have the panoramas work. We've got to figure out what that slice is. So the system that we're going to look at here is how you do that, how you mix a tile world and a spherical panorama. Basically, it's mixing two types of panoramas together. Another important concept here is that if we try to mix these two panoramas together, we have this concern of station point. So let's imagine I'm drawing a 3D world here, basic version of the world, that we put the camera exactly 6 feet from the ground. So that was our station point, 6 feet from the ground. And then we also took the camera and we pointed it down some amount. So if we had the camera 6 feet off the ground and then pointed it down, and we shot a corresponding plate where we put the camera much higher off the ground, let's say this would be our background plate that we're shooting, but then we also shot another plate where we changed the scale of the world. So we basically changed the scale of the world by changing the station point. We scaled the scene up by moving the station point up, but we kept the angle the same. So let's say we made this scene twice as big. We moved the camera up 12 feet to the ground, but we kept the angle exactly the same of the camera. Now, everything that, even if we use the exact same field of view here, everything is going to appear smaller. So if we were to shoot a scene like this with a normal sized person in it, that person would probably get their head, that's a pretty big person, that person would get their head cut off, right, like this. We wouldn't get anything that looked like a miniature version of a person. We would get something that looked like a giant version of a person. In this case, if we tilted the camera down like that, or it looked like a normal sized person, really. But if we move the camera really high up here and shot the exact same person, same height in the real world, we would get something that looked like a much smaller person, even if we used the exact same field of view of the camera. Now, I kind of messed up the angles of my camera just a little bit, but same field of view, same camera, move it up, and now all of a sudden we have a smaller person. So if we take this image, the one that we shot here, and then we try to composite into this scene with the background plate shot from this station point, this camera sort of becomes that camera but it's like shrinking the whole scene down to this size. So the relationship stays the same between the foreground plate of the miniature person and the background plate. So now this relationship, because it's got this much smaller thing, this person would then appear to be something like this big, because that relationship between the two would stay the same. So this background plate would essentially make this person look smaller, shot from this station point. If we wanted to make the person seem bigger, we could do the exact opposite, right? We could say, let's put the camera as low to the ground as we can. And we'll shoot one of the plates, the foreground plate, let's say, or this would be the background plate. We would want to shoot our giant from this, so this would shoot our person on green screen here. But then when we want, so this is, let's say this would be about a foot off the ground. But then we wanted to shoot the background plate that this goes with. We would then shoot that plate, same angle, aiming up from the point of view, or from the height, the station point that we wanted to make it seem like. Maybe not quite 6 feet, maybe like 5 or 6 feet. A normal human height here. And so then the same rules would apply. This plate would appear to scale up by this amount, five or six times. If this was 1 foot and this was 5 feet, it would seem to scale up 5 times. So now you'd have somebody that would appear to be a giant as this relationship scaled with the camera that you moved over there. So hopefully that sort of gives a little bit of the theory of how this works, why it works. It has to do with moving the station points from one place to another, but leaving that relationship between the camera and the subjects. So you have two different, you're making two different station points act like the same station point when in fact they're not. Okay, so let's look at a practical example.